Okay, here's warm up 8.2.2. We've got a sequence here, and we're asked if it's arithmetic or geometric. So what I'm looking for a pattern, and am I adding the same thing to get from number to number, or am I multiplying? And if neither of those things is true, then it's neither arithmetic nor geometric. But so here we are. Well, multiplying doesn't work, but I can see the pattern. It's going down 4 every time. So you can think of it as subtracting if you want, or you could think of it as adding -4. But this one is going to be arithmetic then, because, yeah, we're adding -4 to get from term to term. Okay? And then that means that I can use the specific term formula for arithmetic sequences, which looks like this. Okay, so if I want the 51st term, yeah, I could just build this out till I get to the 51st term, but I'd probably lose count at some point. So this is going to be much quicker to use this formula. So the value of the first term, a sub 1, well, a sub 1 is 42, right? That's the first term in the sequence. I can see it up there. The difference I just found up here was -4. Okay, and then I'm looking for the 51st term, so my n here is going to be 51. Okay, and then I just do the arithmetic and I make sure I follow PEMDAS. So parentheses first, right? And then I'll do multiplication, and the last step would be the addition. Or do subtraction if you want to think of it like that. Okay, so we've got -158, and that would be the 51st term. Okay, if you're looking for the sum of the the first 51 terms, that means you're going to be adding up 42 plus 38 plus 34 all the way until we get to this, right, the 51st term. So without actually building the whole term, we can still get the sum using this formula, and this is just for arithmetic sequences. Okay, so it's the number of terms times the average of the first and last terms. A sub 1 is the first term. A sub n would be the last term here because it'll be the 51st term, right? So when I'm using this formula, yeah, 51 total terms, that's my n. The first term I can see again is 42. The last term, often I would have to do a side problem to find the last term. To find this last term because I can't see it in the original problem. Lucky for me, I already did part B, so I know what the 51st term is. But if I hadn't done that yet, I'd have to use this formula, go through that process to find that that last term is going to be -158. Okay, so let's see. Okay, if I simplify those parentheses, it's going to come out to -58 in there. And then, that's supposed to be 51. Okay, and then the multiplication. And I'll come out to -2,958. Okay. All right. So this is a constant series, which means when I'm building my terms here, yeah, I'm plugging everything from 1 to 29, but there's not really anywhere to plug in the numbers. So in my first term, it's just a 13. There's nowhere to plug in the n, but that's where I would have plugged in the 1, okay? And then, or the k, I mean, sorry. And then second term, nowhere to plug in the 2. So I'm going to keep getting 13s out. And I just really need to figure out how many times I'm doing that. So when you have a constant series, that means I just have a constant number here. You can just take the number of terms times what that constant is. So the number of terms here would be 29, and my constant is 13. So that would put me at 377. It's just going to be 29 13s all added up if I expanded the whole thing. Okay. Here, this is going to be numbers 1, 2, 3, 4, 5, 6, all the way to 29. I'm adding them up again, and my shortcut here, when you have just a variable as your term builder, my shortcut formula looks like this. It's n times n plus 1 divided by 2. Okay. So again, 29 terms here, so I'm going to do 29 times 29 plus 1 over 2. So let's see, that'd be 870 over 2, which is 435. Okay. This is a quadratic series here, and again, there's a shortcut if you've got just a variable squared as your term builder. Here's the shortcut. All over 6. Okay, so 29 terms, and then 29 plus 1 would be the next piece, so that's 30, right? And then 2 times n, so 2 times 29 plus 1, all over 6. Okay, it's going to come out to that, and then that'll put me at 8,555. Okay, that's the end of the warm-up, and I'll see you next time.